如果是个回答那个问题，因为是这样，不要逆行。它是几大之类的？它是几大？一个计划，他自己组织的行业。你想要出去，这还是很想事。因为昨天没搞啊，听那个你的意思是去练比赛的？它是有这个，好像不是。你现在有这些就是目录啊 ，label。我现在主要推你加赛就推那个，然后 test 加赛。上次。我说那种电脑，你把你的上面都看。奇妙，这个反而是对，哦，这个，对吧？就是你得，然后你想过很多事情。我就别来这边待。我这边不自己人的去把。哎，什么？对外学校这个。微马上，我们像真正战斗民民出这种，累的死吧。你看到像这个另外下一帮数据找不到。
Okay. Before the reading link, we have introduced a very simple program that helps us to determine the sentiment of moving Christian. But of course, the program itself is not a serious program to actually apply the natural language the capability that for us to understand the passage. So now we are going to make use of a existing natural language processing tool that allow us to make use of it to determine the sentiments of some short message. In particular, we also give you an example on how to assess, say, short message or so-called twist. Okay, from twist. Okay, because that Twitter organization provide a standard API that we can use to access the tweets posts on Twitter. So we will also see how to do that. And let us begin. So on the internet, there's a lot of resource that we can use in order to solve our problem related to natural language processing. And in particular, in the following that follows, we are going to make use of a particular tool called FLAIR, F-L-A-I-R. That is a simple but powerful tools. A natural language processing library includes many tools that we can make use for us to say use sentiment analysis to determine the sentiment of some of the message that we are interested in. Okay, and these tools not only can work on text classification or natural language understanding, also they can be used for recognition. And we all know that to build a model, a machine learning model, we need to train the model. Namely that we need to prepare a large set of, say, training data, and then we feed into the model and train it. It may take a long time. Okay, but I can just also mention that on the internet, because the natural language processing applications are so common, that there are the NPL communities also pre-train some model. What does it mean? It means that they give you a model that they have already used a large set of training data to train it. So in other words, by downloading this model, you don't need to prepare training data because it has been trained, okay, by someone else, okay, and put it on the internet. And in particular, this FLAIR is a subject tool that there have been some people that prepare a large set of data to train this language model. Okay, so we are going to make use of that. And in this language model, there's a particular, in the API, there's a particular, say, a function that allow us to determine the sentiments of any particular, say, passage directly. So you will see that by using this FLAIR, basically it's very easy. Use it and then ask directly what FLAIR, okay, think about the sentiments of the passage, and then it will give us the answer directly. And now, as I mentioned, not only FLAIR, there's a lot of other. For example, if you are working on your project related to sentiments analysis, then you may find a lot of them. In particular, the other more commonly used tools is the BERT, B-E-R-T, which based on transformer. As I mentioned, transformer is a much better, say, model for us to understand natural language. So, and also there another, say, related tools called BERT. That the training they are just focused on using data, training data that is related to finance. Okay, so there's a lot of such tools, but but the important point is all you need is to learn the simple API, and then you will do almost more or less the same process in order to make use of that to do sentiment analysis. Okay, so now in the following example, we will see focus on two aspects. The first aspect is give you an example on how to use the API provided by Twitter so that you can access the tweets related to some keyword automatically. So this is the way that you are going to access important, say, information from the Twitters. So, but I mentioned that this is one way to access the data. There's a lot of other ways. In particular, you can use a lot of, say, from Bloomberg, from Google. Say, for example, the most commonly used is Google News, that you can use it to access news related to some keyword so that you can also, say, do sentiments analysis based on the news. And also, some of you can even use Google search and focus on news. And then you can also have a much more flexible way to access different news on the internet. So what I want to say is accessing data in order to determine the current sentiments of the population. Okay, that's a lot of other ways. Okay, not only Twitter, of course, we immediately use think about, say, Facebook or even those platform in the mainland China in order to get okay. So and the second, okay, part about our example is how to use French. Okay, so we have two purposes here. And here's the program. In order to use the program, basically, of course, we need to access the Twitters. And we have an API to help us to do that. But in order to combine with the API, as I mentioned, that basically we also use a library provided, okay, so there's a pandas has a library called request. So basically we use request to work with the API in order to access the data. So we need to say import a library called request. And this request you will see, okay, not only for accessing information from Twitter, a lot of other places that we will make use of it. Okay, so this is a very important platform for us to access data from the internet. Okay, also we need to import the FAIR for us to do the sentiments analysis. Okay, and here is not that particular relevant to, okay, our example here, but the point is, in order to use the Twitter, I need to, a few years ago, I need to apply for a Twitter account, not an ordinary Twitter account, but a professional account. And in order to apply it, I need to answer a lot of questions and also explain why I need this account. Okay, and then eventually they give me this account. So in the first few years, I use this account to demonstrate or how to access data from the Twitter. But and also I also give the password to our students so that they can try it. And by giving their password, I kind of beg our students that just use this password to say try the example that I use it okay, the Twitter account without doing any other thing. Okay, otherwise I will be in trouble. I'm so foolish that every year, okay, we have 150 students taking the course. So over the years, several hundred students taking the course. So basically, you have no way to guarantee that there's no one or two students who are kind of a rubric and don't care about what I'm saying. And in particular, last semester, when I tried to use the run the example again in order to prepare the class, suddenly my account was blocked. Okay, so of course I'm kind of panicked. Okay, and I sent email to Twitter why I cannot access it. Then they give me a reply saying that okay, I promised to use this for educational purpose, but eventually they find that I use it to develop some apps. Okay, use the Twitter to add the app. Okay, and then they violate the promise, so it blocked my account. So now I cannot use my account. Okay, and fortunately we have two levels. Okay, for the app is is version 2. So basically, I was brought in the version 2 that you can see. So now I still can use version 1. Sorry, in this example. Okay, so now I'm kind of a little bit say mature now. So I will not tell you the password again. Okay, so I will just save it somewhere in my local computer. Okay, and then when I use it, I just open it and then read it from my local computer. Okay, so I just feel bad about it. Okay, because I think it's kind of fun to really try this out. Okay, but anyway, this is what things force me to do that. So this is let me get through. Okay, so now for this one, okay, Google App import file is just for me to read my text file in my local computer, in which this only contains the password. Okay, and of course I need now you may delete it. Okay, so this is kind of repeated. Okay, now this is a simple function that allow us to get one tweet at a time for it. Okay, but anyway, in order to understand it, you need to know the structure. So let us say know the structure of the data that we get, and then we can go back here to find out why we want to do that. But in particular, and this I can tell you what we want is to give a large sequence of information for every tweet. You just extract some of the important information or some information that I'm interested in this example, namely that I want to find out the ID of the tweet, the creation time of the tweet, as well as the most important is the text of the tweet. So that's based on it, we will do the sentiments analysis. Okay, so now you will return it to this function. Okay, again. Now, as I mentioned, we have two purposes. The first is to prepare the data. And as a matter of fact, if you work on a project with related, say, application, then you find that it is kind of straightforward by following the API to get the data. And here is it. So the most important point, as I mentioned, is make use of the library called request, okay, and implement by pandas. And this request implement different a large number of say a small program for interface using the API of various say software platform to get data. Okay, so this is a very useful library request, and from request it's called the method called get in order to get the tweets that I want. And then of course, this request expect some argument that I will it needs in order to communicate with the tweeters, okay, platform. The first is the address, the URL for the request to connect to the server of the Twitter. So you see that basically it's a URL from the server. And the version of this server is 1.1. Okay, so for 1.1, I still can use it now. Okay, Twitter have not got. But later you see that when I try to use another version, it's 1.2 or 2.1, I forgot. Basically, it's another newer version. Then basically for that service, I was spotted. Okay, but anyway, we use the URL to select the server to get the data. And they have the API which has a set of rules to tell us what we need to put as the general parameter. In particular, you can see that I specify what the query. Okay, what kind of query that our interest? The keyword is Tesla. So whatever the tweets contain the keyword Tesla, then they will pass it to request for us to process. And the tweet mode is extended mode. So basically, this mode will kind of specify what kind of data that I will get. So extend mode, I will get not only the date the text, but I can also get the creation day and other related information. So I'm choosing the extended mode. And if you look at the Twitter's homepage, then you see that there's many other modes that are with different purposes. Okay, you can check it yourself. Okay, the language for the Twitter basically is support not only English but French and also from other language. So I specify that I want only tweets from that are written in English. So English tweet, and count is the maximum number of tweets that I want in one single bank of getting the data. So this is the parameter. Okay, so we call it once, then it will get at most 100, let's say, tweets. Okay, in the return, or we will put it in the response. Okay, and then the last thing is very important. So it's for giving the password. And in Twitter, they call it a bare token. Okay, so it's authorization. Basically, it needs this a string for headers, give the authorization, and I need to supply the bare token. Okay, where to get the bare token? Basically, I just store it in my local computer, and all I need is just to use the file, background to read it. Okay, so you don't need to say pay attention to this, because if you know the actual password, then you just replace it by the actual password here. Okay, so this is not related directly to what we are thinking. Okay, so now it prepare all the necessary arguments in order to get the tweet. So when you call in, then you will get at most 100 tweets related to Tesla, in which the message are written in English. Okay, so now next, what I'm going to do is to build a data frame, that is the table. And in this table, I will use the interface to get a tweet one by one, at most 100% of them. And in the tweet that returned from the request.get are very complicated, lot of, say, information that I don't care. Okay, so I will just go through this list of tweets, and then we will only extract 3 fields: ID, creation date, as well as the text of this tweet. and I will say build a data frame that every row essentially is containing this tree. So for every tree, we have a row containing the ID of that tree, the creation date of that tree, and then the text. Okay, so basically we are going to do it one by one. How to do that? Call PD pandas data frame to create an empty data frame, empty table. Okay, I call it twist. TWT. Okay, now here I just for treat in the response. So you will see that this. Okay, later next in a minute I will explain it. So this part you can see that it will get the trait one by one. Okay, so you can imagine that this is a list of traits containing a lot of information for every trait. So I just use the for loop to get the traits in the list return one by one. And then for every trait, as I mentioned, contain a lot of field in order to get the path that we want, that for every trait, okay, it has which is a dictionary. Then there's a key called ID string, okay, and then its value will be the ID of the trait. A key called created at, then the value will be, okay, the date, the time that this script is created, and also you have a full text. So this basically this function is just extract three fields from the text, okay, and the tree basically is a pandas dictionary. Have a lot of say key value tags, and many of them are not of our interest. Okay, so I'm just pick three of that example here. Okay, now in order, so this is basically given trees by tree. So let us look at it a little bit more deeply on what this okay to give us. Okay. So now for JSON, I suppose many of you already know that. So basically, in the internet, there's many servers and many group of say software designer to work on their own problem and build their tool and then put it on the internet so that other people may use it. The major problem is that this different group of software implementator basically have no say a global agreement on the format of the data. So it will encounter the problem that different software implementator will post their tools that require a different, say, communication format. So you need to kind of learn their communication, say, format in order to use it or get the data and then pass it to another server. So the communication between different servers on the internet are always a major problem. Okay, so in order to solve this problem, then some global organization will design a format called JSON, okay, JavaScript Object Orientation. This is kind of a universally agreed, say, format for communicate between different servers. Okay, so this is the JSON format. So it's for data interchange. So it doesn't matter whether your organization has used this data format. But at the end of the day, if you want to communicate your tools or your result to another, say, server on the internet, then you are required to convert the data into this format called JSON format. Okay, so it's just a very simple, say, so-called interchange format to communicate between different, say, entities in the internet. So, so since this is so commonly used, so the response that we get from the Twitter interface, that this object have a say a method called JSON that will convert the format returned by the say Twitter's interface into we write it into a JSON format. So this is why I call it in order to kind of not learn the format that is used by Twitter, but then it just call it to get a JSON format. And in fact, partition format is essentially just a Python dictionary. Okay, the Python dictionary in which this is only a list of key value pairs. Okay, for those in our application. So it's very easy to use. After calling say response.json, so you will get a list of dictionary, where each dictionary corresponding to one tweet. Okay, and the dictionary basically have a lot of key value pair. Okay, one particular key value pair is called status, and this status is gives you the detail of each tweet. So this basically get all the tweets one by one. Okay, so this will give you a list of a dictionary, where each dictionary for a tweet. So this for loop will just get the dictionary one by one. And the dictionary lot of say key, so you can get the data. So here get data basically is just only get 3 keys, namely the ID, the creation time, as well as the text. So we'll only get the 3 fields. And then after that, then we will just return a list called row. Okay, so this is what we will see here. Okay, so we will get today return the data that is returned essentially is a dictionary again that will just copy the ID string field of the tweet, which is called ID, and then another field called created at, and then the tag. Okay, so this will give you a dictionary return, and I will just use it to append it as a row to our data string created here. So you will see that essentially what we are going to do, first create an empty data frame, and then use the JSON response to get the dictionary one by one, the returned by the request.get. And each dictionary contains information about one particular tree. Okay. So what I'm going to do is upon all the key value pair in the dictionary, I just abstract 3 fields corresponding to the ID, creation time, and the text, put it into the dictionary, and then convert it into assign it to a new row of the add a new row to the trees. By what we have processed here. So one by one. And since we add a row and we just want to say forget about all the indexing, say complexity. So I just kind of tell it that when you attach the whole table, just forget about the index. So it will only give you the position in order to access the tree. So this is basically what we are going to get. So you can see that when you get the response to JSON, in particular, that is a very, which essentially is a dictionary. And each dictionary, of course, has a lot of key value pairs. The first one is called status, and you see a long list. Each each entity is a dictionary, long list of dictionary. Each dictionary corresponding to information about the twit that you show. Okay, when it is created, its ID in terms of integer, in terms of string, and they will also get the full text and also gives you a lot of other information that is none of our concern here. So this is why I need only say extract of them and then put it into the data frame. Okay, so eventually, if you run this, you will get a table like this. ID created as and then the text will create one by one. Okay. Now, so now what we get is this table that after using the twist the API. Next, based on this table, we have 3 columns. And what I'm going to do next is to use fair to check the text of each of the row in the table. That means check the text, the twist one by one. Okay, and then we will append 2 columns in this table. One column will be the sentiments. Okay, we call it the sentiments, which is called value of the pair given to that particular twist. So the value will be either positive or negative. Okay, so this is what fair will tell us. If the twist to the text to fair, this model will do its own analysis, and the output will be a value, whether this is positive or negative. So I'm going to create a new column in this data frame that I've prepared, such that this column will associate with every twist in the row the value returned by the fair models. And also, the fair not only will give the score positive and negative, but we will only also give not the value, but also a score. For this score, basically you can say regard it as the confidence that fair will feel about his recommendation. So for some text, of course, there's a lot of positive word, then of course fair will be quite confident that this text will be positive. Okay. But for some more neutral description in the tweet about Tesla, that's not many positive words and not many negative words. That basically, even though they decide eventually that the tweets are positive, it's not that confident that indeed this is positive. So in order to take care of this kind of level of different level of confidence, in order for us to have some kind of better idea on whether we should trust their advice. So fair will also associate with its a value suggestion is a score, the confidence level or score. So if the fair are pretty certain that the tweet is a positive, positive sentiment, then the score will be close to 1. Okay, so it basically it will you can also treat it as a probability. Okay, so it's how probable this tweet are indeed a positive sentiment. So this is a score. So you can see that I'm going just what to do is to create for each tweet of every row in the data frame, compute the score and the probability, as well as the sentiment value, and then you have two columns. Okay, so basically what I'm going to do is extend the table by calling fair to work on the tags so that the fair will column show the probability returned by the fair as well as the value that determine about this one. So I'm going to create these two tables, two column and a primary table. How to do that? Basically, append two column is very easy. Okay, so you just create a vector or whatever that store of is columns of value. Then you just get a new column with the name called probability and assign what you have got into it, and do the same for sentiments, and you will get two new columns. Okay, the key point now, of course, is to determine the probability and sentiment. How to determine? I'm going to go through the tags of every row in the database because every tag is corresponding to one grid. And then I will call fair, to analyze these tags. And then based on the result of this fair, then we will put the probability as well as the sentiment and going to corresponding to row one by one. Okay, so it's not that difficult. Okay, just all we need to do is to go through. Now this is the table. We go through the table one by one, but not everything, but just focus on the column for tags. So if this for loop, this tree will extract or go through the tags one by one. And for every tags, that we get, we'll call fair to do the analysis, to make the prediction, and then get the score and value. And then send it to the probability and sentiment. Look at it one by one. Once we complete all the analysis, then we send it to the row. So what we are need to complete the detail, we'll be looking at the fair. As I mentioned, the fair is a model that has been pre-trained, under different language, different application. So in order to use it, then of course you see that I've already imported the fair. But after that, then we need to tell what kind of the function that we need, what model that we know. So immediately I should say call to get the model. How to do that? In the fair library, I call the model, and then the model I will want to say work on a text classifier. Now, for text classifier, that means that I want to find a machine learning model that has been trained already. And basically, because there are a lot of different models. I want the one that is in English and then related to sentiment. That means that I'm going to load the machine learning model that has been trained especially for English, and they will determine the sentiments of the English practice. So this is specify the model that I want in my program. Then by calling this one, we will download the model that will handle discover the sentiments of an English text. And of course, after that, we just say get the model and store it in some name. I call it the sentiment models. Then after that, then basically now we can call the model immediately. So in order to do that, we need to do a little bit extra preprocessing. So why we call it preprocessing? So remember, given a passage, basically what you get is just a sequence of letters. And this sequence of letters is very difficult to analyze. Okay. So usually a natural language processing tool will not work in this lattice level, but instead it will first break down, okay, the whole sentence into meaningful unit. And for us, meaningful unit is the word. Okay, it will break down it word by word, so that it will need is to handle the word instead of handle the letter and see how they are going to work. Okay. So basically, before we just pass the say text to the model, that model will expect us to break down or group the letter into the word so that it will have an easier way to analyze that. Okay, so in order to make use of this sentiments model, which will expect that the input will be a tokens of word. So we first need to kind of do some preprocessing to break or to group the letter into a token or a word. Okay, so in order to do that, basically we call this function for sentence from fair. Then the sentence from fair, basically you'll see in this example. So the input or the argument will be a sequence of letters corresponding to some alphabet. But you can see that it is very difficult if you just kind of put yourself in the position of analyzing just a sequence of letters. Okay, and this by calling this a function, basically it just kind of update the sentence, okay, to give more information. In particular, after calling that it will internally convert, okay, this sequence of letters into a collection of tokens. In this example, it tells you that after the analysis, there are 5 tokens, 5 units. Okay, the first unit is hello, the second unit is comma, third is I am happy. Okay, so basically it just kind of does a little bit, say, preprocessing to help the fair model to do the analysis. So this is what you need. Okay, so you first convert the list of say letters into tokens, and then this now sentence will be say the information it contains is the sequence of tokens. Okay, and then you just make use of the model that you download here. It's a model. Okay, and now you don't need to train it, remember, because this is already been trained, pre-trained. Okay, so this is you can directly use it to predict. Okay, call it with your sentence. Okay, that are working in terms of token, and this one basically will the predict will work on the sequence of token in order to decide whether together they will represent a positive sentiment or negative sentiment. Okay, so after calling that, you see that they just call it. You do not need to assign any return to result. Okay, so in here there are say implementation essentially will not return anything, but instead it will modify directly the sentence. Okay. So after you call predict, so before you call predict, basically after you do the preprocessing, it's just a sequence of 5 tokens in sentence. Now, after you call predict, okay, then you see that there's much more information. After calling predict, then you say that, okay, it's still hello, I'm happy, and also 5 tokens help you. But in addition to that, then there's another new field okay, called labels that will give you, okay, these two very important information is the value that fair determine this tactic, either it's positive or negative, together with the level of confidence of the conclusion. Okay, so after you call, okay, this fair predict, then the sentence will have, okay, a standard to include the result. This too is the major information that we need, okay, in our application here. How to get it is very easy, okay. The sentence dot label, that you see that this is a list, and the first item will be contain the score and value, so we call score and we could call value in order to get the level of confidence and the sentiment. So each one you go through it one by one, get the levels of confidence as well as the sentiments, and then you append it, okay, one by one after you process every test. So basically, you have two sequence of value. Okay. And finally, we just assign this sequence of value as a new columns of a table. So eventually, we will get, okay, we'll get this table. So what we have done now basically is kind of say straightforward. We use the Twitter's API to get the tweet one by one, and then we just each tweet will be say corresponding to a dictionary. Then we will just assess, okay, this each dictionary, the key for the ID and the creation date as well as the tag, and then we just create a data frame. Then after that, then we call say fair, that is a pre-trained model, so we can just go through this data frame and then extract the text, pass it to the fair model. First, we pre-process it in order to convert the letters into tokens, and then pass this sequence of tokens, okay, to the model for pretext, and then basically each such a sentence will give us a probability as well as the result, and then we get this data. Okay. So this basically is show you a simple example of how to make use of the fair. Okay, but this example not only restrict to fair, as a matter of fact, you can just go to the Word homepage. So for example, all you need is just to figure out the API, and then you make a minimal change. And the simple will do the same thing. Okay. So basically, if I were you, I have time, I would also say modify this program so that instead of using fair, I try bird, I try invert. Okay, do the same thing and then see, okay, how much difference that this free model will give us. Okay. So here is some simple example of making use of, say, some pre-trained model in order to help us to determine, okay, the scientific. Okay, now the example here is not complete in our discussion, because we in this topic we always want to say combine the sentiments analysis to the real stock price in order to see whether there's some kind of a relation between the sentiments of the general public as well as the stock price movement. Okay, so basically after all this year, we, as I mentioned, is always say not surprisingly, is the sentiments and the stock price have a very obvious correlation. Not day by day, but maybe just 1 or 2 day lag, and then they shift a little bit, and then you find that a very, say, close relation between that. Okay, but as I also mentioned, that it doesn't mean that sentiments analysis will help you, because the correlation doesn't say tell you anything about the causal relationship. Okay, whether which is the cause and which is the result. Okay, so of course we want to say argue that the sentiments is the cause, and this sentiments say change will affect the stock price and make it change. But in general, I find that is totally reversed. Okay, the stock price change will say kind of affect general sentiments about that stock. Okay, so if this is the case, then it will not have any, say, very say significant application for using it. But anyway, of course, this is kind of something that needs to be discussed or argued. But at the very beginning, let us see how to say create sequence of sentiments in order to compare it with our stock price. Now, what we are facing in this problem are somewhat different from what we are, say, facing on the previous example. For the previous example, basically, what we need is to just ask the API to collect 100 tweets for us to build the table. Okay, and the tweet usually is the most recently, say, posted tweet in order to get the data. But however, this will not be enough for us, okay, to solve our problem, because we want to see, okay, for any particular day, that the sentiments of that day, how does it affect the stock price on the same day? So in other words, it is not enough to just get the data. We also need to specify the time of the day in order to get data. So in such a case, so this is why the previous, say, API are not enough for us. Okay. So we are using another API, Twitter, that will also allow us to specify the date in order to assess tweets that has been posted around the period that we specify. Okay, so this is one problem. The second problem, if you really say look at it carefully, or you will immediately aware of this problem if you really write a program. So one major, say, technical difficulty that a general data analytic application, okay, programmer will face is how to handle time. It is not that easy, because if you remember, and for the time will be specified the year, the month, the day, the hour, the minute, and second. Okay. Now, what we want is not just specify the time, because in our case, we need to write a program that will manipulate the time. Okay, either advance it for another hour or go back some minutes and so on and so forth. Okay, just imagine that the input will be 2023, month is 08, and then 31, say for example. Yeah, and then you want to get also the time, and then you want to find, okay, the time that is 10 minutes later. Okay. Then you will be in big trouble. because if the time is kind of 11 o'clock at the night, that when you advance it by another hour, say for example, then you need to change the day. And if you are at the end of the year, then you also change the year. And also you have a leap year. So that in some situation that when you advance it, then you will have February 29, okay, and some year you do not have first. So what is the handling the time is not as easy as you say aware. It's very difficult. Even though your program can handle some of the case, but eventually if you are not careful, eventually your program will get into big trouble later. For example, if your program worked very well for ordinary year, but your program forget about the handle leap year, so pretty sure 4 years later, notes that the program will say advance the time correctly. Okay, so since this problem is so important and is so difficult to handle, so almost all not only in pandas in Python, but in language R and other say commonly used language for data analytics. So one of the major package that we always need to learn is how to handle tasks. Okay, so in this example, basically, it's also a very good say opportunity for us to see okay how to handle time. So not only for this example later, when you need to work on some say application that need to work on time, modify it, and you can make use of it. Over here, okay. And another part here, I will not go through it. Okay, it's called how to clean the data by using regular expression. But it is still okay. Other details here. So basically, we will just skip it. But this basic, you can, if you really want to know it, it's not that difficult. You can just go in the Google, try to figure out the library called RE. RE is a short form for regular expression. So this library makes use of some, say, representation, a format called regular expression for us to specify some non-trivial pattern for us to say detect them in our tree in order to either remove it or make change to it. Okay, so basically it is just for cleaning up the content of the text. But as I mentioned, for the fair doesn't really care. Okay, you just use the whole text and then you work on that. Okay, but of course, if you clean the text, then it will have a higher probability that the fair will give you a more sensible result. Okay, but this let us skip it. Okay, and now here is the version 2. Okay, another it's not 1.1. So this one a little bit more complicated, allow us to specify a time period so that the API will just return trace post on that period. Okay, and this is the parameter, and in here you will see I did not specify the time period in this parameter because I will repeatedly use the interface to collect okay trace from a various period. So we will call okay this interface again and again and again, such that every time I call it, I will specify a period so that I can collect okay trace of that period in order to determine the sentiments of that day. For example, Okay, so this is why I will not specify the period here because I will specify in the main program. And this is just some header that we put it here so that we do not need to repeat it again and again in the main program. Okay, and this is the password. Okay, so it's kind of complicated, more than say 50 or 60 characters. Okay. Okay, so now for this example, not only will say work on the fair to determine the sentence, but for me is also very important is how to make use of the library to manipulate time. And the library to manipulate time is called datetime. And the datetime basically is a couple of library. What we're going to do here is to, use the sublibrary also for datetime. And also this is called time delta. This time delta basically is for us to advance, a certain amount of say minutes or hours. Okay. Now this DT format, I will explain it later. Okay. So let's skip it. Okay. So now, and the example you will see now quite clearly. Okay, if you look back to the, so you can imagine that the format of the table is something like this. Okay, and so if this format is now, then we want to get the time for say 60 minutes, 1 hour early. Then it in general is easy, or just minus. Okay, now this is hour. Okay, and minus it by 1, and then you can have it. But if the hour basically when you minus is become negative, then maybe you need to change the date. If the date at some point you also may need to change the month and also may need to change the year if the minus will just advance past, today or past the month or past the year. Okay, so it is quite complicated, but we don't need to handle it ourselves because time date provide this function called time delta. And this time delta basically will first convert the duration that we want into the format that is suitable for it to handle time. Okay, and then after that, so this is the format that tell us how to handle 1 day. Okay, additional. And then it can have a kind of a plus or minus that is working not on number but work on date. And this one basically is the current time and that minus 1 hour. So that the result will be the time 1 hour early. Now you can see that it seems that it is quite easy, but in fact it's not. Lot of say possibility that you need to handle. Okay, but you don't need to worry about that. You just use it to do the do. Okay. Now here basically is what I'm going to do. Okay. Okay, so basically, no, maybe. So I'm talking about daytime. Daytime has a function method called .now. So this will return the daytime of the current moment. Okay, so we have now here by calling now. And what I'm going to do is to first, I will from now, I minus 10 days. Okay, so minus 10 days. And record is last week. Don't put too much say attention on the name. Okay, let's call this day last week, and this is now. Okay, in fact, so the kind of in between that's 10 days. Okay, so basically what I'm going to do is to divide it into hours. Okay, we divide it into hours so that I will iteratively call the API to get the treat for the first hour, previous hour, and then I will try subtract another hour in order to get another hour, an hour by hour in all. So basically, we keep on reducing the current time, by hour. So now, and then I subtract 1 hour, then we have a new time, and then we have a period of that hour. After that, we get the twist, and then we subtract another hour. Now, so basically, our window will be moving backward, about hour by hour. Eventually, it will move past this boundary last week. In this case, we will stop. Okay, so basically, you will see that I will collect the tree among these 10 days. And for each of them, I will try to make use of fair to get the sentiment. Okay, so this is what I'm going to do. And how to do that? Okay, it's very... Well, let's go through it. So I call now, in order to get the data. Okay, but you see that I'm doing I'm kind of slow. Because if I specify the now, and now basically, if you pass it to say Twitter, then the Twitter do not have the necessary response. So to get us all the tweet that has been posted up to now, because it is kind of too close to the posting schedule. So I find that if we specify the actual time now, and then we call it the Twitter, then from time to time, we just cannot get the tweet, and then it just hangs. Okay, so in order to avoid this kind of nuisance, so now instead of working on exactly this moment, I just divide it by 1 day. So we collect data 1 day earlier, so to make sure that the tweeters will kind of update the database in a stable way, so that when I get the data, I will not get into trouble. If I set to now, basically the database is not already stable, and sometimes it will kind of crash and make my program doesn't work. Okay, so hope that you understand. Okay, so now so this is kind of treated. Okay, but obviously I got now, but we have a new now, and then what is the last week? As I mentioned, then we will move back day by day, until 10 days early. So this last week will be 10 days earlier with the same time. Okay, So what I'm going to do, of course, is we will keep on update the now by minus 1 hour, 1 hour, 1 hour, okay, all the way. Okay, and of course, every minus will advance the day earlier, so eventually, okay, it will reach last week. So as long as now is smaller than last week, okay, no, as long, so we will quickly doing this processing, but as long as we find that now the current time has passed last week, the left boundary, then we break, do not the end. Okay, so we keep on moving back 1 hour and 1 hour. Okay, until it passed last week. This is now minus 10 days. So this is what we have. What are now next? Go back. Now, go back here. Okay, you want to move back. Here, go back. Go back basically is I do not need to make this function. As a matter of fact, I just for now I do minus say 15 minutes. So every time I just from now I find okay the time 15 minutes earlier. Okay, so now we have current time and that 16 minutes earlier. So I want to assess the trace post during this period. So basically, the starting time will be okay 16 minutes, and then the ending time will be now. Okay, so this is the parameter that I have not complete in the header part here. Okay, because I need to update it okay time to time in order to say get the trigger in that time period. Okay, so this is it. So now, and I want to spend some time to explain this. Basically, the internal representation of data is rather complicated, but I work on this data structure itself in order to manipulate the time. But however, when you want to specify the API of trigger, okay, then you cannot use that data structure because the trigger has its own API that needs to be formed. In particular, that the trigger requires that when you want to spend time using the API, that time must specify the format that you can check it in their homepage. Namely that, okay, if you want to change it into specify a time, so you need to specify the year, and this is a capital letter means that you need to specify the whole 2023. Okay, sometimes in some representation it's 23 would be enough, but it is 2023 the computer, and then 2 digits for month, 2 digits for day. Okay, and then you have a key here in between. So this is the format key to get following by 2-digit hour, 2-digit minute, and 2-digit second. Okay, and then on the same string that will terminate as .000 that. Okay, so this is the interface requirement. So this is what we need to provide in the start time and end time in order for the API to work correctly. Okay, now then you will be kind of don't know what to do. Okay, don't worry. Okay, because daytime provides us the function called create a string from time. Now this is the create and send from that. So you have a current time in the basic structure of daytime. Then this function will convert that daytime into a string. Okay, then how to do the conversion? You just specify as an argument the format that the string will look like. So this is the format. So you can imagine that when you call this one, then it will return the current daytime, okay, in terms of this format. And this is exactly what the trigger requires. So you just put in the parameter starting time. Do the same for the end time. Okay, then you specify the period, and then you just call request using the parameter which specify the starting time and end time. So you get the period, and also the period will contain the keyword either Tesla, TSLA Tesla or not. Okay, and the range English. Okay, Chris, maximum result is 10. I'm lazy. Okay, normally you can say to 100, but anyway, I'll just say to 10 and so to that. Illustrate what you do. And also, the trick field that I want is also created by. Okay, so this is what we have done. So after that, then this is now very similar to our example earlier. So after get the response, return by request.get, then you can get the data by calling response.json. And then it will give you a list of a dictionary. That dictionary will help you, each dictionary corresponding to the details for 1 to 3. Okay, now here is what I spent few hours to figure out. So when I just say go through the menu, basically it is easier to create this for loop. So at the very beginning, I just have this for loop, and I find that sometimes it works correctly, but sometimes it will say kind of break down and hanging and stop and give you error message. Okay, and after say a few hours to check it, I find that basically the problem is okay that so we extract the trace every hour, but it happens that at some hours there's no trick related to Tesla and that kind of thing. So when you call it, basically there's no trick on the trick. Okay, and then if I just insist on getting the data during those hours, there's no trick. That means that the corresponding data, say dictionary, do not have the related information, and I will, on my program, will say get in trouble. Okay, so finally, I find that in order to make my program work under whatever condition, so I should first check whether the result on JSON indeed has a field called data. Okay, so if that period indeed have some trait related to Tesla, then there will be a keyword called data, and then that keyword will be associated with the information about the trace post at that period. So I need to at least check it earlier, okay? And then if that's indeed the data, then this is what we have done earlier to kind of extract the creation date. I'm lazy now. I forgot about throw away the idea, just get the creation date and also get the text. And in this example, I make use of the regular expression to do some cleaning up, but it's not necessary. Okay, just pass the text. It will also give you the kind of score as well as the probability. Okay, and also for the treat, the creation date. Just say, look at the results and just extract, okay, forget about the year, the time, and just focus on the month and day, okay? So basically, it's extract the month and day to put it in my table, okay? And then I just kind of row by row as what we have. Okay, so for this example, this part is similar to what we have done earlier. So the important point is how to, say, manipulate the time, making use of data. Now, this is a very useful technique, trust me. Okay, if you really want to do data analytics in your application, from time to time, you need to handle that. Okay, and this is a very useful tool for you. Okay, then after that, then you just create this one and create the table, and then you get the result. Okay. And okay, so for after say we create the table, then this is more or less the same of the last example. But what that's a little bit different is we want to combine the level of confidence together with the value predicted by the fair models. Okay. Instead of separate them as a say positive or negative together with a level of confidence, so we create a new concept called weight sentiment. This weight sentiment basically is just say take the score as a weight in order to say to adjust it, using it to adjust the positive and negative. So in order to do that, then we will kind of encode a positive by an integer +1, while the negative is -1. So whenever you see a number 1, then you see that this is a positive. When you see a -1, that is a negative sentiment. Okay, and if you see a 0, that means that you have no say particular conclusion about that. Okay, and in order to combine with the confidence, so we will consider the weight sentiment, which is just the multiplication of the probability of the level of confidence returned by fair times the sentiment, which is 1 and -1. Okay, so in this one, then you know that if the probability is close to 1, or sentiments is equal to 1, that means that the fair will have pretty confident that the sentiments of the test is positive. On the other hand, if the probability is still 1, but the sentiment is -1, then the weight sentiment will be very close to -1, and this tells that the fair are pretty confident that the test of the sentiment is negative. But of course, no matter what the sentiment is, but the fair do not have any say confidence on it and set a level of confidence close to 0, then no matter what is the score, what is the value, then the weight sentiments will close to 0. So by just look at the weight sentiments, we have a pretty good idea on combining the confidence as well as the conclusion of the fair. Okay, but after say create this column of weight sentiments to replace this two columns. Okay, the column for probability and column for sentiment. Okay, and then we use this to do the analysis. Okay, and finally, we will use the group by that create that we will group all the twists that are created at the same time, and then we look at the corresponding weight sentiments, and then we just get the average of that. So that at that particular time, that we have an average of the weight sentiments of all the tests posed during that time. Okay, so this is what we have done. Okay, so after that, then what we get is since we create this focus on only have the month and day. So essentially, it will grow for every day all the Twitter create on that day, and then we just use the average of the sentiments of the Twitter create on that day. So this is the average of the rate sentiment of the Twitter create on that day on February 16, February 17, and so on. Okay, so this is kind of the sentiment. Okay, and then you see the result is the Tesla, all the sentiment are more or less negative. Okay, any question? Good. Okay, so eventually we have prepare a table. In particular, it has a sentiments which is the like this. Every day we have a sentiment. So we have sentiment in this table. Every day that we group all the weight sentiments of the tweet on that day and do the average. Okay. So in order to compare it with the stock price, okay, and then of course we here it's not that often. We just call use Yahoo Finance to get the stock price of Tesla. Okay, remember the Tesla basically you need to specify the period of the trading day. So start with the start day and end day. The start day and end day, of course, is the time of now as well as last week. Okay, so this is what. And then after that, we got the stock price. Then we do just kind of list the stock price so that every day we will say have a index of the stock price. After that, we just plot them out. One for the sentiment that we plot this table out. Another is the stock price. Okay, for every day. Okay, so basically you will see that the relation of the period that around sentiment. Okay, and if you look at it carefully, okay, so the stock price increased from 13 to 15. So you see that okay, the sentiment on say in between 16 and 17 and 18 are still dropping. Okay, that means that this will not affect. Okay, this price increase has not say enough time to affect the general opinion about the stock. But at 218, then this effect of increase, okay, on these 3 days of the stock price have some positive effect that it will kind of raise the public say sentiments on stock price, and then it will kind of increase. Okay, and also at this point 215 it decreased, then it takes a little bit of lag time that not until say 2 days later it will drop. So you see that the stock price will have effect on the general sentiment, but not immediately, but with a lagging time about 2 or 3 days. Okay, so this is what we have seen. So in other words, essentially it's no use. Okay, it's kind of a reverse. As a matter of fact, when I was a little kid, then our parents have always told me that okay, to invest in stock. The most important one is if everyone say that stock is very good, you need to say spend your whole say sankara, everything in buy it and don't trust it again. Okay. So sometimes sentiments not have a positive going on. But anyway, this is what so of course this is just a kind of problem to see how you can make use of the current technology. Okay, but also at the same time, don't trust talk too much on the current technology. Okay, so in order to get the real, say, power of current technology, we need to actually work on the field. Okay, enough in order to see what is suitable, what is not suitable, what kind of technology work for your problem, and what kind of technology doesn't work for your problem. But anyway, this example just one very important, say, truth that I'm sure that is very useful to data. Okay, because handling data is a kind of a very, say, tricky problem in data analytics. Okay, very good. So we finish our discussion on sentiment analysis. So in the next part, we will work on a new topic with fault tolerance. Okay, and we will let us take a 15 minutes break, and we will return at kind of 40, 45, 50 now. Okay, so 8:50. Okay, so we will return.
Yeah. We briefly finished our project.
Yeah.
And I want
Yeah. It's November 2nd.
Yeah, right. Okay, so let's see.
Kami na kayo na.
Mhm. Right. Okay, so today, uh, 26.
Yes.
So November 2nd was the last lecture. And then, okay, it's November 9th and November 16th. So these 2 days.
We'll do the presentation.
Yeah, that's right.
And what is the due of our submit our group project on Moodle?
Good project.
Yeah, do this.
Uh,
It's about 9 or.
maybe 1 or 2 weeks later. I'm not sure.
Oh, we present before the submission.
Yeah, of course.
Oh,
We make the presentation first, and then spend 1 or 2 weeks later to submit the report.
thank you.
Okay, and every day, we will have 3 parallel sections. So in total, there's 6 sections, and we will present in one of them. So now, next week, and then we have presentation here. We have 3 sections.
We have 3 sections.
Yeah. So 3 classroom.
Oh, 3 classroom.
Yeah.
So TA will.
Yeah, because we
evaluate.
Yeah, we have 2 theory and myself, and each of us will handle 1 section. Okay. And then we will give the grade as well as give the comment. Yeah, so this is what. Okay. Okay. Okay, so let us start another topic. It's about fraud detection and prevention. Now, for this application, different problems may have a different difficulty on their concern. And for this application, basically, the most important part or the most difficult part is not the machine learning part, but the data cleaning part. So to say develop tools to handle fraud detection, basically the data that we based on are not the data like the stock price. Okay, it's pretty straightforward, because for this kind of application, we need to work on documents, handle originally manually, but so there's a lot of mistake and some missing data and that kind of thing. So for fraud detection,
basically one of the major effort that people put in is to do the data cleaning and preprocessing to make the data in such a clean the data in such a way that it will be free of say mistake, typo, or whatever abnormality in the data set to clean it out, either throw them away or use some intelligent method to correct the mistake, so that eventually you have a kind of a clean set of data for you to do the machine learning. Because garbage in, garbage out. What if you want input for the training are full of mistakes, then the signal that is necessary for you to build a model will kind of say overshadow or kind of misled by those say typo and mistake. Okay, so you see that in order to handle this problem, you need to learn those standard say data cleaning methods. And also later you will see that the problem also that the fraud detection, the data essentially you will see that most of the data are negative. They are normal, say, transaction. Only a few of them have been fraud. It's normal because fraud something illegal. Most of us will not do illegal say, action. So only a few transactions will belong to say fraud. So you see that in the training data, a majority of the transactions are all say normal record, only a few of them are fraud. But in this case, then it will kind of confuse the machine learning model, because if it encounter most of the normal legal transaction, then basically it is it in its learning, basically it just have tendency to say everything is normal. Okay, but most of the data is normal, then it will kind of put a heavy weight of say judging a transaction is normal. Then basically you will see that if we use a say a whole data set for training, the result will be kind of biased to normal transaction. And in such case, the model will not be too useful because it will miss those important fraud cases. Okay, so this is kind of the problem that we need to handle. Okay, so so it's a little bit different from what we are facing on the some previous application. Okay, but this fraud detection and prevention application are very kind of important in such way that because that it shows through the fraud detection and prevention market. That is the company on the software institute spent the time money on solving this problem. You can see that it increased quite dramatically. That means that every year they will spend kind of a significant increase on the money invested in developing software for fraud detection and prevention. Okay, so this is a quick market. So this is why there's a lot of say development in this area. Now, I already mentioned that the technical problem of this fraud detection on the input data set but there's also a little bit higher problem. Okay. Basically, we cannot just focus on the technical side of the software. Still, we have other constraints, okay, in our application. In particular, we are kind of dealing with an entity that are our customer. So the customer satisfaction is very important. So we cannot impose, okay, any measure that will make our customer feeling that we are unnecessary harassing, make the say experience of our service, okay, negative. Okay, in such a case, that it will kind of hinder our say kind of the market to satisfy the account. So basically, when we decide a measure for handling and preventing fraud, at the same time, our measure will also, we need to consider, okay, they will not kind of creating or introducing too much unnecessary bad experience to our customers. Okay, so this is kind of a constraint that we need to consider when we dealing with developing software. So not only focus on the technological side, but still we need to also look at the business side in order to make our system reasonable. On the other hand, so this is what we need. And how does machine learning help here? And you will see that basically it is what talk about the trend and you understand. So before computer introduced, and the bank, other financial institute, in order to say handle this kind of essential fraud, they will manually going through the transaction and pick out those that they think that they are problematic. Okay, and then from this set of problematic, say, transaction, okay, they have a term called flag. Okay, they flag it problematic and normal transaction. And based on this flagged transaction, they try to say discover manually the pattern, okay, that are shown in this transaction in order to figure out, okay, the property or something that you need to be aware of to check in order to flag those abnormal transactions. This has been done manually for deciding the rule for the tracking. At the same time, it needs handled manually for every, say, transaction. We need a, say, personnel in the company to go through the rules in order to determine whether that transaction indeed can be an abnormal transaction and need to be flagged. Okay, so this is one before computer, both determining the rule and checking, but it can have to be done manually. But after the introduction of the computer, basically one part, namely the checking part, can be done by the computer. So, and in this say period, what the financial institute is doing is that, again, they need to say collect all the problematic abnormal transaction that they should be flagged, and then they look at, okay, this normal transaction to discover the pattern, the feature that indicate strongly that this transaction are problematic. So the rules are determined by human being, determined manually. But once you have this rule, then you don't need to check the transaction manually, but instead you just encode this rule in your computer program so that for every transaction, you just run the program, which will check the transactions according to the rule. And if the checking flag the transaction, then of course it will pick it out and for manual, say, handling. Okay, so this part basically still the rules for checking are handled by human being, but the actual processing of the checking can be done by computer. But still, that's a problem here. Is when you say discover that something is wrong manually, it will take a relatively long time because you cannot say do it in real time. So you need to collect the transaction and then get enough data, and then you manually check the data one by one in order to get. Okay, so it's still the problem here in this approach is that it is not respond quickly enough to any new kind of attack. Okay, so basically you will find that someone discovered a very clever way to cheat the bank, okay, by doing some illegal transaction. And of course, after a period of the time, the bank will discover kind of natural losses on the profit, and that they will collect the transaction and look at and say, there's a new practice that you can see in the transaction that is also cause us illegal. Okay, but then it will kind of wait a longer period of time for the bank to discover this kind of abnormal transaction, as well as to discover that the positive feature that will kind of show that this transaction is illegal. So, but then this problem, people are started thinking about using machine learning to learn, okay, those rules or those characteristics. So basically, this will make things make the bank with a much faster response time to the possible, say, attack of this kind of transaction. Namely that they will kind of collect all the flag transactions that the bank has been, say, handled, and all it needs is to, say, collect, okay, a big selection of the transaction. Some of them are labeled normal, some of them are labeled fractured, positive, normal. Okay, that's every day they can just put this, okay, for the computer machine learning algorithm to train a new model. And of course, if there's some new characteristic involved in the fraud transaction, then we will expect that the machine learning model after a training will discover it, so that the next day using this new model, then it can now handle those newly, say, high fraud technique. So this will make everything automatic, not only for the checking of the rule, but the updating or creating of the rule will be much faster and automatic. Okay? So in this case, then we can handle any new tactic. from the, say, illegal, say, action to handle. Okay, so this is one of the major advantage of machine learning, namely that they will automatically discover the pattern among the transaction in order to flag the abnormal transaction. Okay, and for this method, then basically again, you will want to say have a high accuracy. That means that it will have a small number of false negatives. So in this kind of detection, okay, then there's two kinds of error, okay, that we need to distinguish. One error is called false negative. False negative, that means that the transaction is indeed fraud transaction, but your machine learning model say that it is okay. It's negative, no problem. Okay, so this is called false negative. Another kind of error is called false positive. That means that this transaction is okay, but your machine learning model decided that this is a fraud detection. Okay, and this is on. Now, so this kind of say error are kind of have a trade-off between that. You may adjust your system or the machine learning model in such a way that it will can say have a very small number of false negatives. Okay, because it can say okay, and tendency is say everything is positive. Okay, then it will have a relatively small number of false negatives. But then it will cause you trouble because you say everything is false and negative. That means that many of them are indeed positive. Okay, and they are fraud, and then they will say cause you a lot of say trouble. Okay, when you allow this kind of transaction without any say prevention of that. Okay. While for the false positive, you still have a problem. Okay, because now every customer you can they have this kind of error. That means that maybe the customer, many of them are normal customer, but the system just say that the transaction is positive, but they are wrong. Then it will not eventually will cause immediate corporate loss or problem about your company, but then it will kind of create a very bad user experience of your customer. So eventually you may lose because you lose the customer. Okay, so these kinds of error still have significant impact on the profits of your company, even though the way they affect the loss are kind of different. Okay, so good machine learning model should make sure that both of them, not one of them, will have a small number. Okay. Also, as I mentioned that again and again, that during the training you should avoid overfitting. And as a matter of fact, this overfitting problem is even more important in this problem because, as I mentioned, that many of the transactions are kind of negative as normal transaction. There's only very few of them are kind of a normal transaction. So in other words, the signal are dominated by this large amount of legal transaction, and basically your system may kind of tendency to say, okay, introduce many false negatives in order to to identify that small amount of positives. Okay. And again, the overfitting basically as the data, okay, the negative data is not that much, so it is kind of easy to design a model that is overfitting the negative data on the hand, so that it is kind of overfit the model with the other kind of mistake. So anyway. So again, that show that in order to make the machine learning tool work well, okay, in this application, the most important part is the preprocessing of your data. Clean up your data so that it is good enough for you to train the model. Okay? And this is some other difficulty of the problem, but you read it yourself, okay? More is going to make sense. Okay, so now, in order to for this, I just want to show you what needs to be done and what kind of pandas methods that you may use in order to say clean up the data. Okay, so in order to see the application, then we have I've already uploaded and you can track it. Basically, I just kind of create in whatever way, okay, a file, which is a comma separate value file format that it will kind of showing the transaction of a company, okay, that is kind of an internal finance they handle. So this is the file that we want to work on it, and we want to say from it each transaction, we want to develop a machine learning model so that we can identify those fraud transactions in this data application. Okay, now, and in this data immediately we see that we have problem with this data set because this is quite normal. For those data set that is obtained manually, there will be many mistakes, and one of the most common mistakes is some of the entries of the data set will be missing. Okay, so in order to work on it, the first thing is when you get the data set, you have to say figure out in this data set how the missing data is represented. Okay, so that when you read it, then you can be focused on this particular signal in order to make your data frame correct properly. Okay, and in this data set, we find that we use the colon to represent missing data. Okay, so now in order to say read in the data set into our program for further handling, all we need is to make use of the pandas read CSV method, and then this is the file that you see earlier here. Okay, in particular, you should specify telling the read CSV method that in this file, the entry with the value colon represent say missing value. Okay, it's called NA value, not a variable. Okay, not a variable. Okay, so it's NA value equals to colon. So when you do that, basically it will read the file and then convert the file into a data frame such that each row will be one single transaction, and each of the row corresponding to column for a particular, say, feature about the transaction. Okay, and what is the feature? Basically, once you do this transaction, you will see that, okay, there are 6 columns, 7 columns, starting from index 0 and index 6. Okay, so this is the table that we read from this transact record CSV, and it has the column for amount of the transaction number, the status of transaction. What is it? Status of transaction. That means that, okay, whether the transaction has been checked and determined that they are paid with consult or paid and with consult, that is whether it's approved or not. Okay, and then of course the department are involved in this transaction, the fiscal year that this transaction involved, and then the month. And the last column, most important, is the model answer, okay, of that transaction. So you can see that this red flag column will put a, what is it? Put a value of 0 if transaction is normal, and put a value of 1 for the transactions that are fractal, and should be some transactions that you need to bring attention to the company personnel to check. Okay, so you see that after, say, reading the file, you will have this, say, big data frame to work on, and the data frame will be something like this. Okay, and I would just want you to pay attention to what happens to the missing, say, data. So in this CSV file, so you use colon to represent data that is not available or missing. So if we work in this way, then when you create the data frame, then the missing data colon will be replaced by a special value supported in pandas called NAM. Okay, it's kind of a funny name. Okay, we say that this value is not a number value, not a number. But anyway, this NAM putting into the data frame, and the pandas have various methods for us to handle NAM value. Okay, either detecting them or replacing them. So this is very important that when you create this, say, data frame, you need to replace all the colon character for missing value to NAM, so that after create the table, then all the missing value is in NAM, then you have the necessary method to handle. Okay, so if you do not do that, and this is still colon, then the method provided by pandas working on NAM will be of no use. Okay, so this is very important. Okay, now once we have, say, represent those problematic missing values by NAM, okay, then basically we can say call some function. Okay, one particular function is the function called any. So for any, it will work on every column, and it will give you a say an answer is true if that column has some row is NAM value. Okay, so by calling this any in the data frame for our data set, then I see that in this table, every column will contain some NAM value. Okay, so most of the all of the columns are problematic for the missing. Okay, now and among. I don't know why this is 0. So anyway, the NaN value are true. One of them. Now, this is another function that if you work on like a whole data frame, or you can also work on a particular column and call is null, then basically for this column is now maybe okay. So for example, you call df say among. Okay, dot is null. Okay, so this is the column. And this is the value, say among is 13, 25, and then NaN, and then 100. Okay, so maybe. Okay, 100 and so on. Okay, basically, this is now is for every, say, entry here, it will return false. If it is not an NaN value, it's false. Okay, here is true. And this is false. And so on and so forth. Okay, and since we know that in the internal representation that pandas use 0 to represent a Boolean value false, so 0 and then 1 for a Boolean value true. So in other words, all among this column, okay, that will be a 1 if the corresponding value is a null value. Okay, so this is what we will get here. Okay, and then if you call sum, then the number will be equal to the number of 1 in this column, and each one corresponding to 1 NaN value, null value. So this sum of this one is just show the number of NaN on NaN value appear in that column. And if instead of applying is now to one single column, but in its whole data frame, then basically pandas will apply is now to every column. And for every column, then it's now you see that every entry will be replaced by yes, okay, false or true. Okay, so you have a true with the corresponding value is an NaN value, and false if they are normal value. So this is the is null, and then you call sum them up together is to be equals to number of say 1 in this column. So this equation is showing the number of, say, entries in this column that corresponding to NaN value. So here you just see that among is 0. I don't understand. Okay, because you say that that's among has NaN value. But anyway, at least the transaction say number column have 44, at least 44 say value that is NaN, and status is 41, and so on. So what does it mean? It means that it is kind of important that when we import the data into our program, that make sure that you have to specify what say is the symbol represent the NA value. because after you just use it, convert it to NaN, then you have, okay, many of the useful function or method that you can use to get information about the distribution of this NaN value. Okay? And once you determine on this column has many NaN values, how to handle those NaN values. Okay, there's two common way to do that. The first common way is to remove the whole entry, whole row. Okay, in this row or whatever you have in this row that has NaN value, then you can just call drop NA to remove the whole row. Okay, another way to handle NaN value will be just to replace it by some number. Okay, sometimes you replace it by 0, or sometimes you replace it by some commonly appear number. Okay, or in this case, you just use the mean of the column to as the value. Okay, substitute the NaN value. Okay, use the mean. Okay. Now, you see that this is not specify the column, but the whole data frame. So you would say, expect that basically it would repeat the whole process for every column. Okay, this statement will just repeat the process on every column, set for every column, for all the NaN value appear in this column, that it will replace this NaN value by the mean of the non-NaN value appear in that column. Okay, so this is also a very commonly used method. Okay, now here I want you to look at it, then you will find there's something interesting. And now the data frame, I find that, okay, this column and this column, both of them has NaN value. Okay? Now, when I do the processing, so what I'm doing is I cause field NA, mentioned here, and try to replace the NaN value in that column by the mean of the non-NaN value, okay, in that column. So basically, here is exactly what I will extract. For this NaN, the mean of the remaining will be 214.5 something. So you see that after execute this statement, then the NaN will be replaced by the mean. Okay, no problem. Okay, but on the same data frame, if you look at this column, and we also want to apply the mean and replace the NaN value, but you see that it has no effect. Okay, because after calling this function, this column, the NaN value is still there. The reason is very obvious, because this column are not numbered. So there's no way to determine their mean. So pandas just ignore it. And you do not replace any value by NaN because it do not know how to find the mean. As a matter of fact, this method can only work for columns that are numbers, either integer or either floating point number, but it does not work for character column. For this one, what should you do? Basically, of course, you should not replace it by mean. You should replace it by some character string. Okay, but it's kind of difficult to design the right character string to be. So for this one, usually we just called drop and A, to drop the whole row. Okay? Instead of using a new value. Okay, so this is social way to handle NaN. Okay? And before I move on to the outline, I want to say that I just oversimplify. Okay, the process. Basically, the preprocessing are much more complicated. Okay, because not only the NaN, for example, sometimes, okay, this value itself will have, say, kind of lot of things to handle, because for this one, okay, and for the typing, then you now this is, I just want to give you a general picture on the difficulty of handling, say, cleaning the data. For example, many of the input data, that the full stop will always have a typo called comma. Okay, instead of type 2016 dot blah blah blah. Okay, that's some typo that 2016 comma blah blah comma 7. Okay, so basically, as data analytics, you need to kind of detect this error and then replace the comma by dot. Okay, and this is not difficult, but still you need to handle it. Okay, right? How to do that? Basically, you make use of a pattern matching, say, method to detect whether the value here has comma or other, say, character. And that if yes, then you just replace that character with a dot. Okay, and so and also, and this, say, APR and September, that kind of thing. Okay, and you still, your data cleaning should make sure that they are belonging to the 12 months. Sometimes, okay, the data here, they are typing something not equal to 12 months. So as SEP, then have SEPT, okay, and then it will also make it. So what I'm saying is, I oversimplify the tedious and difficulty in handle this kind of data cleaning. Okay, so but anyway, this is one of the parts that will take much, say, effort in order to do that. And if you take a real data science course, and that's will have a large portion of session will do the data cleaning. Okay. Now, in this data set, also we want to identify something called outlier. Now, this kind of outlier, that means that their value are significantly different from the normal value that appear in the data set. Now, this outlier is, in our example, is very important signal, because if the value are different from normal value, that means that the transaction is not normal. Okay, so this is a kind of a very strong signal that we should tag this data up. Okay, but the problem is, what do you say mean by an outlier? Okay, and of course, this is not a subjective method, and we try to make it as objective as possible. So in this situation, the statistician basically have a formal definition of outlier. Okay, so that no matter which application developed by which, say, software developer, basically they use the same definition on line. Okay, so before we leave, so let us talk about outlier. Okay, in order to understand now outlier, we need to know quanta. Okay, what is quanta? Basically, if you suppose you have a data set, and if you list the data set, okay, from ascending order, so this is the minimum, and this is the maximum. Okay, it's called X mean and X max. Okay, and then you just divide this number list into 4 parts by 3 numbers, Q1, Q2, and Q3. So Q1 will be the number such that, okay, in the list there are exactly 25% of the data smaller than it. Okay, so if you have 100 number here in the list, then the 25 number will be Q1, because that's exactly 25 number, okay, smaller than or equal to 8. So this is called the 25 percentile of the data set. Okay, usually called Q1. Q2 is the median. Okay, 50% is smaller than that, and Q3 is the 70% of it. Okay, so if you list the number in ascending order from the X smallest to X largest, okay, then you can divide it, the whole data set into, okay, by these 5 numbers. Okay, X mean, Q1, Q2, Q3, we call it the 5 number summary. Okay. Now, how can we use it to determine the quanta? Basically, in order to determine the quanta, then you have the concept of the interquantile rate, which is the difference between, okay, the actual value between Q1 and Q3. So this is the, okay, so this is the data, okay, of the data, and this is the largest one, and this is the smallest one. Okay, so sorry, because the direction is a little bit different. So this is Q1, this is Q2, and this is Q3. Okay, so now in order to decide the outlier, the major consideration will be something called the interquantile, is the difference between the value of Q3 and Q1. Okay, so it's the length of it. Okay, and then this is the length between Q1 and Q3, and we blow up, okay, 1.5. So we have, okay, and so this length is 1.5 times the length of IQ R. Okay, the length here. So it's 1.5 times the length here. Okay, so this one, okay, basically, any data that was greater than this one are called outline, larger outline. Or if you just look at this one now, we don't have outline in the other end, but just imagine that, okay, you have some data here, then you do the same thing, that you just, okay, draw a line whose length is equal to 1.5 of the height here. Okay, that any part smaller than, okay, that extended length basically is also not outline. Okay, so basically it's 1.5 of the difference between Q1 and Q3. Okay, that anyone larger than that is outline, or anyone smaller than that is okay. So this is the, okay, our definition of outline. Okay, and in order to say kind of outlier will give us a strong signal that the corresponding record will be, okay, something that we need to take attention. Okay, so this is about outline. Okay, so maybe we stop here. Next time we just do something to clean the outliner, or we want to say make use of the outliner to give us a signal for protecting crop. Okay, so basically, all the techniques here are kind of a commonly problem involved in data cleaning. And in real practice, there's a lot of, say, things that you may need to do. And you cannot avoid it because if the data set are full of error and mistake, then the training will be of no use. Okay, so let's stop for today. And for next week, there's not too much to cover for this one. We're almost finished. Then we will move on to the optimizing. Okay, and then we have enough time to do some. Okay, so and forget the mention about the project. Don't worry, I have urged our TA to post the final arrangement on the project presentation. You check Moodle and you will. Okay, so that's all for today.
今天白干买不去了。
係話其中一個。